Hey y'all, in this lesson we are looking at being able to understand relations and functions. We want to be able to identify functions by their equations, tables, and graphs. We have some key vocabulary. The y-intercept, this will be the same as initial value, which is important when we look at word problems. And the slope is the same as the rate of change. If the graph of a function is a straight line, it is a linear function. You see the word line in there. If the graph of the function is not a straight line, it is a non-linear function. You literally see no and linear in that word. Our essential question is, what are different representations of a function? In our first example, we are going to look at identifying functions from a graph. We want to determine whether each graph represents a function. This is actually really easy. We have something called the vertical line test, which says that I can draw a vertical line anywhere on a graph, and as long as it touches the graph of the function only once, then it is in fact a function. So again, looking at this second one, I could draw a line anywhere. It only hits that blue line once. So each of these graphs represent a function because each x value corresponds to exactly one y value, which is essentially what we are testing with the vertical line test. However, this last one, if I draw a line, you will see I touch 2 points on this curved graph. This graph does not represent a function because each x value does not correspond to exactly one y value. Here at -2 for x, it hits both 1 and 5 on y, so it's hitting 2 points. So this is not a function. So it's easy to tell if a graph is a function or not. Your try it is to draw a graph that represents a linear function. Remember what I said a linear function looks like. Also, try and write the equation that represents the function you draw. In example 2, we are going to look at representing nonlinear functions with a graph. So how can you determine whether a relationship between side length and area is a function? Well, when we say between side length and area, we're thinking about a square. We want to look at the side lengths and the area of a square to figure out if those are a function of each other. So step 1 is to make a table that relates those things. So we have the length of a side, 0, 1, 2, 3, 4, 5, and the area that would be. Since a square is the same on both sides, the area would be that number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. Each input value has a unique output value, so the relationship is a function, right? I'm not going to do 4 times 4 and suddenly get 20. It doesn't change. So this is a function. However, when I go to graph these ordered pairs, I see that it does not form a straight line. I can see that it is a function. Remember our vertical line test. However, it is not linear because it is not a straight line. Our final example will deal with a word problem and representing a linear function with an equation and a graph. We want to be able to use different representations to determine different things. In this scenario, a 10,000-gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool and into the tanker. How can you determine how long it will take to pump all of the water into the tanker? We can see we're pumping out 720 gallons per hour. We can see that there are 2,000 gallons in the tank so far. So we're wondering, in how much time will we get all of the water out of the 10,000-gallon pool and into the tanker? One way is to look at this using a diagram that represents a situation. So we can see we draw a rectangle that represents the whole 10,000. We know that 2,000 has been taken out, and then we can put 720 for every hour, and however many 720s would be the number of hours. So the amount of water that's already pumped, this is our initial value. or the y-intercept. The amount of water that is pumped every hour, this is our rate of change. So you see on this half of the equation, our rate of change times our variable h plus our initial value. It's just like mx plus b, but instead we have an h instead of an x. On this other side, they've set it equal to 10,000 because that's the total amount of water to be pumped. Another way would be to represent this on a graph. We can use the information, and you can see again, 2,000 gallons have already been pumped. This is our y-intercept, or our initial point. The tanker pumps 720 gallons each hour, so the slope is 720. So they go up 720 every time they go over. And the graph of the function is a straight line, so it is linear. And you can extend this line all the way up to 10,000 to figure out how many hours it would take. So in that previous example, the pump is pumping water. The amount of water still in the pool is decreasing at a constant rate. So complete these statements, then graph the function. Again, remember that in that scenario we were just looking at, we were pumping into the tanker. Now we're looking at what would that same scenario look like from the view of the pool. So the amount of water remaining in the pool is, if 2,000 has already been removed from the 10,000 gallons, what's left? The amount of water pumped each hour is, this will be the same amount from last time. They're still pumping the same amount per hour. Use those two values to write an equation, and then graph that on the graph provided to you. Summarizing our representations of functions, you can represent a function in different ways, in a table, in a graph, or as an equation. We can see an example here of one scenario being represented in each way. A day at the amusement park costs $10 for an entrance fee and $2.50 for each ride ticket. So you can see in the table the cost and the number of tickets being bought. In the graph, the initial cost is $10 and it goes up $2.50 for each ticket. Under the table, we can see the equation that represents this function. In the third example, we are just showing off again that the graph of a nonlinear function is not a straight line, but the graph of a linear function is a straight line and has a constant rate of change. Your next steps are to submit your 4.2 notes, complete your Build 4.2, and take your 4.2 mastery check. Then continue on to the next lesson. Good luck!